properties of exponential functions, we want to consider the inverse of the exponential function, which is the logarithmic property, or the logarithmic function. It has an essential property of log base b of x equals y, if and only if b to the y equals x. The first is called the logarithmic form. The second is the exponential form. We can use this to convert from one to the other. If we know things about exponentials, we can convert it to an exponential and use some properties there, or we can convert for an exponential function or an equation into a logarithmic form and work there as well. Now there are three rules or properties of logarithms. These are very similar to exponent properties because they're related. So the first is the product property. What happens is if you have a product in a logarithm as an argument, that can be written as the sum of the logarithms. The quotient property, which takes a quotient and you can write it as the difference of the logarithms. And then the power property, which is my personal favorite, can take exponents and actually write them as just a product, as a coefficient. Now we'll use these as we need them. But let's look at example 4. Solve each of the following equations for x. Now, what I'm going to do here is actually introduce a logarithm. And it can be any base. Okay, so it can be any base, but I'm going to use log base 10. So I'm going to take the log of both sides. Then I can use property 3 to bring my x down. So that is x times log 5 equals log of 2. Now log 5 is just a value, so I can divide by log 5. Which makes x equal to log base 2 divided by log, or not base, log base 10 of 2 divided by log base 10 of 5. Now since I could have used any base logarithm, I could have done log base 5 actually. That would have been very helpful, as we'll see later. Or I could have done natural log. So this is actually equal to natural log of 2 divided by natural log of 5. Both of those are equal, so any of those would work. All right, part B, e to the x plus 6e to the negative x equals 5. What I'm going to do is actually multiply both sides by e to the x. What that will do is that will give me an e to the 2x, because I'm adding the exponents there, plus 6, that will cancel, equals 5e to the x. Moving all this on one side, you may not see where I'm going, but hopefully it'll be pretty clear in a second. E to the 2x minus 5e to the x plus 6 equals 0. I can actually write this as e to the x squared minus 5e to the x plus 6. And I can factor this, actually. E to the x, e to the x. That'll be a 3 and a 2, both minus. Since that equals 0, this indicates that e to the x minus 2 equals 0, or e to the x minus 3 equals 0, which means e to the x equals 2, or e to the x equals 3. Taking the natural log, which will be very helpful here with a base of e, x is equal to natural log 2, or x is equal to natural log 3. Example 5, solve each of the following equations for x. Natural log of 1 over x equals 4. This is a place where writing it in the exponential form might be useful. So it's a natural log, so it's assumed to be base e. So I can write this in my exponential form as e to the 4 equals 1 over x. And then solving that for x, cross-multiplying, or however you want to envision that. But I'm going to take the reciprocal of both sides, and I find x equals 1 over e to the 4th. That's the best form of that, of course. Now, I can't divide by 0 in my original equation, so x can't be 0. That's great. 1 over e to the 4th is not 0. So that's perfectly fine. All right, part B, log base 10 of root x plus log base 10 of x equals 2. I'm going to solve this for x. I want to point out a couple of things. One is that base 10 is actually assumed. So if it only said log of, that would be just fine. Now, another thing is property 1 in reverse. I actually have a sum of things out of the same base. So what I can do is multiply the arguments. So log base 10 of root x times x. So I'll just write this as x root x. That equals 2. Now x root x is x to the 3 over 2. X to 3 over 2. All right, so I can then bring down my exponent. That is property 3, the power property. Actually, we have room right here. That leads me to 3 over 2 log base 10 of x equals 2. And then multiplying by 2/3. That means log base 10 of x is equal to 4/3. Now I can write this in the exponential form, which is 10 to the 4/3 equals x. And that's as far as I need to go because that is my value of x. So x is approximately 21.5443. We of course verify that. 10 to the 4/3. Yes, okay. My calculations are correct. So either of these would probably be acceptable. However, the first would likely be preferable. Both close, but the first is exact. I want to leave that probably. All right, part C. Natural log of 2x minus 3 natural log of x squared quantity equals 0. Okay. First thing I want to do is write this as natural log 2x minus natural log of x squared cubed. That way, I can have 2 natural logs with no coefficients. I can write that as x to the 6. Now, there's a difference there, so I can turn this into a quotient based on property 2. So that is 2x over x to the 6. Right, now, simplifying that, and I'm going to go ahead and convert this into exponential property in the same move. This is going to be e to the 0. E to the 0 equals, and that will simplify to 2 over x to the 5th. Let's move over here. So 1 equals 2 over x to the 5th, which means 1 equals, so I'm taking the reciprocal, x to the 5th over 2. So 2 equals x to the 5th multiplying by 2, and then x is equal to the 5th root of 2.